let's discuss the importance of units. There's different units for mass, different units for volume, different units for time. There's different units for counting things, where you're looking at a number of things, or a number of atoms, or molecules, or ions. Are units important? Go to Google, and Google's NASA's mistake for omitting units. And you're going to find a very interesting story of something that happened to NASA in 1998. NASA had spent $125 million on a Mars orbiter and sent it to Mars. And the engineers that were working on the Mars orbiter, they were engineers of Lockheed Martin, they used different units of force. One group was using the units in terms of pounds per square inch. The other one was using a Newton to calculate force, which is a kilogram basis. Pounds and kilograms do not correlate with each other. They're not directly related to each other. However, the engineers they kept looking at a number for force, a number. And one group assumed it was the Newton, and the other group assumed they knew it was in terms of pounds. So when they sent the Mars orbiter into space, it burned up, along with $125 million, time, effort, and money, because they omitted the units. So units are extremely important. There's different units for the metric system. Hopefully you've watched the metric system, metric conversion video, where there are different prefixes of the metric system. And then I'm sure you're familiar with our English system of things like pounds and feet and yards, etc. So not only is it important when we record a number or report a number that we include the units that go along with that number, but it's also important to note how many significant figures or significant digits are in that unit or in that number. And you can often, I will refer to this as sig figs. There's an example of this in your book. In this ruler, we will pretend that these are inch measurements. If I were to want to measure the length of this object, how would you record the length of that yellow pencil? Again, we're going to pretend it's in inches. You would not report that as 3 inches or as 4 inches, because you can clearly see that it's somewhere between 3 and 4. So what you would do is you would probably report that as what? Maybe you would say 3.4 inches. Maybe you would say 3.5 inches. Both of those would be correct. You would guesstimate a decimal place for reporting that number. Okay, what if I changed my ruler, and we'll still pretend that this ruler is in inches, but this time we will include a halfway point, and maybe there were even further divisions here so that we could actually measure tenths on this ruler. And I'm going to attempt to draw it at the same distance. So what kind of measurement would you record for this ruler? Well, do you see that we can actually be more precise with our measurement? This second ruler gives us a tenth place, but we can still mentally estimate even a digit further. So this one might be 3.45 inches. We can become a little bit more precise with our measurement. And you should always focus on doing that. You can't do this if you're using a digital device, whether it's a digital scale in your bathroom or a digital scale in the lab. But anytime you're using a device where you actually have to look at and measure the number yourself, you can always record 1 decimal place beyond what that device gives you. So if we're looking at the length of this yellow pencil, which measurement is correct? Is it 3.4 centimeters or is it 3.45 centimeters? The answer is that both of those answers are correct. It would depend on which ruler we were using to record the length of the pencil. And that's where the term significant figures comes into play. It's defined to be all the digits in a number representing the data or the results that are known with certainty plus 1 uncertain digit. So, in this first number, when we said 3.4 centimeters, we have 2 significant figures because the 3 is significant and the 4 is significant. In 3.5 centimeters, likewise, there's 2 significant figures, the 3 and the 5. When we record this number, however, 3.45, there's 3 significant figures. As long as your number is not 0, it is a significant number. If it's 1, 2, 3, 4, 5, 6, 7, 8, or 9, that's a significant number. The question comes into play when we're dealing with zeros. Is a 0 significant? Well, whether or not a 0 is significant, it depends on where the 0 is in a number. A 0 can be at one of 3 places. It can be at the beginning of a number, a 0 can be in the middle of a number, or you can have a 0 at the end of a number. Depending on where the 0 is determines whether that 0 is significant or not. A 0 at the beginning of a number is never significant. For example, it's not common, but if I wanted to report the number 123, sometimes we can see that reported as 0123. That 0 is not significant. The 1, 2, and 3 are, but not the 0 because it's at the beginning of a number. Now, it's not very common to see zeros reported like that at the beginning of a number. However, a lot of times we see them after a decimal. If we said 0.0123, those zeros are still at the beginning of a number. They are not significant. 0.0123 only has 3 sig figs. That 0, this 0, is a placeholder. Now, just because we're calling it not a significant digit doesn't mean we can just forget it and report this instead of 0.0123 as 123. Doesn't mean you can erase it. It simply means you can't count it as a significant figure. What about zeros in the middle of a number? Zeros in the middle of a number are always significant. For example, 101, well, that 0 is in the middle of a number, or another way to say it is it's in the middle of 2 non-zero digits. So the number 101 has 3 significant figures. If I reported 5,006, those zeros are also significant because they're in the middle, and of course the 5 and the 6 are. What if I reported 0.0408? How many significant figures are in that number? 3. The 4 and the 0 and the 8. The zeros at the beginning, refer back to rule number 1, are never significant. Now, the last rule for significant figures. Zeros at the end of a number. Zeros at the end of a number are only significant if they also come after a decimal. So for this last rule, you have two qualifications that must be met. They have to be at the end and also after the decimal. You can't have one or the other. It has to be both. So if I said 0.010, this number has two significant figures, the 1 and the 0, because this second 0 is at the end of a number and it's after a decimal. This 0 is after a decimal, but it's not at the end of a number, so it would not be significant. Only the 1 and the last 0 are significant. Let's practice. I will give you some numbers and you decide whether these numbers are significant. How many significant digits, that each number has. 147, 203, 0.690, 0.2040, 0.0180. You look at those and tell me how many significant figures each number has. In 147, there are 3 sig figs. All 3 numbers are not 0, so they're all significant. In the next example, 3 sig figs, because zeros in the middle of a number are always significant. In the next example, 3 sig figs. Zeros at the beginning, never. Zeros at the end, yes, if they also come after a decimal, and this one does. What about the next one? Zeros at the beginning, never. Zeros in the middle, yes. Zeros at the end, yes, if they also come after a decimal. So this number has 4 sig figs. What about the next one? Zeros at the beginning, never. Zeros at the end, yes, if they also come after a decimal. So this number has 3 sig figs.